So, good morning. Let me quickly check my sound. That sounds good. So, then, welcome to day 6 of Advent of Code. And yeah, let's get right to it. Day 6, Trash Compactor. After helping the elves in the kitchen, you were taking a break and helping them reenact a movie scene when you over-enthusiastically jumped into the garbage chute. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door's been magnetically sealed. As you try to find a way out, you are approached by a family of cephalopods. They are pretty sure they can get the door open, but it will take some time. While you wait, they are curious if you can help the youngest cephalopod with their or her math homework. Cephalopod math doesn't look that different from normal math. The math worksheet, your puzzle input, consists of a list of problems. Each problem has a group of numbers that need either be added or multiplied together. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, yeah, here we got the input and we are interested in the vertical calculations. Each problem's numbers are arranged vertically. At the bottom of the problem is the symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. The left-right alignment of numbers within each problem can be ignored. So this worksheet contains of 4 problems. 1, 2, 3, yeah. So here this 1, 2, 3 times 123 times 45 times 6. Yeah, that's this one, and then 328 plus 64 plus 98 is this one, and so forth. To check their work, cephalopod students are given the grand total of adding together all of the answers to the individual problems. In this worksheet, the grand total is 4,277,556. Of course, the actual worksheet is much wider. You need to make sure to unroll it completely so that you can read the problems clearly. Solve the problem on the math worksheet. What is the grand total found by adding together all the answers of the individual problems? So, I think this task is, quite doable, but yeah, probably I find a way to make it overcomplicated. So let's head over to Visual Studio Code. And yeah, here we still have our day 5 solution open. Let's copy again day 5 and make it day 6. And then rename all the important parts. And then we can simply place this, remove the range type, the extension methods and everything. And the helper method. And that should be what we need. Then let's go over to the module and declare the day. Looks all right. Then I head over to AOC again and quickly copy in the test case. So this is our test input. Let's comment out the test B. And we can also remove this little test. And then we can head over Yeah, I headed over to AOC again. And here we can plug in the number that is expected. So that's our input. Then let's rename this to day 6, of course. Remove the unused import, and we can also go over here to the main and add day 6. And yeah, so when looking at this, I would say we should simply split on new lines. And then we can split on white spaces. And then we have, I wouldn't flat map it, I would just map it. And then we have a vector of vectors that isn't as useful right now. But then we can zip every line we have. And as a result, we should get, an iterator where we have the multiplicator with the different numbers here. Let's start by so let's take our input and split it on new line, and then let's map all the lines, and let's say split white space. This will split by white space. Separate by any amount of white spaces. That is the important part, because I see here we have multiple white spaces and we need to be able to also split on multiples. So then we collect this and we collect that, and then we say, I would call it grid for now, and then this is a vector of vector answer. Yeah. So now we have our grid. We could make this mutable. Why is there no... That's odd. Why don't I get any type hints? Is the Rust analyzer not working? Was just working. Okay, it just has a problem with the name grid. Apparently. Okay. I don't know. I think it thought the 0 was supposed to be the method. I think I have to give my cat some more food right now. Be right back. I'm back. So yeah, the one cat always leaves some food for later. But our other cat would eat that food if we don't protect it. So we have to lock it in a room and put it up on the counter, and then have to, serve it again later. Yeah, so we have a grid, and we could check if we can pop the last element. Removes the last element from a vector and returns it or none if it is empty. Those are the operations here. That's perfect. We can unwrap, because otherwise If this isn't the case, then it should panic definitely. So, but we need them as strings. I wouldn't know what else. Yeah, okay, so, but now we know that in the grid only numbers are left. That is good. But now let's look if we can zip it. Or row in grid. Row dot zip. Oh, we could probably reduce. So then our accumulator starts to be the first element of our collection. And then the rest follows. We could say into iter because we want the ownership of those vectors. And then we say accumulator iter zip with the next. This says mismatch type. Found expected struct. Ah, okay. So we need to collect this again and say vector of. But what is it? A value of type vec_answer cannot be built from an iterator of and. So what does zip do? Returns a tuple. So then it would be a tuple of tuple and tuple of tuple and so forth. That's definitely not what we want in this case. But we could, of course, say map. Okay, so first let's use fold here because we definitely need to fold. And we need a vector of answer. Or let's not say answer. Let's directly use U64's new. I think we need it like this. And yeah, so zipping it will. I think zipping it is a bad idea. I think we can actually just mutate the collection for this. So let's say we would say next for each for an element in next. We can simply say accumulator dot last dot push. So let's first start by saying this is the vec macro with a vec macro in it. So then we definitely know there's one element at the start. We Still thinking how we can do this. We could, of course, try a get. Yeah, get at the index. So then we can say enumerate here that would lead to us not only receiving a next, but also receiving an index. And then we could say get the index, or else we could say give us a vector, and that would be our collecting vector, which we can unwrap actually because we already have an or else, right? Returns the option if it contains a value, otherwise calls f and returns the result. Yeah, so we can unwrap that here. I don't know why it still returns the option in that case. Well, I think I have to let the cat out again. Be right back. I'm back. So we have a vector. This will now be at the correct position, and then we should be able to simply say push the element. Yeah, we have to make this mute, otherwise this won't work. But we don't just want to push, we have to say parse to AU64 and wrap that. Now we have a reference to a vector. And then we should say accumulator. Is there a set? No. Maybe just maybe we should build that list beforehand. So maybe do something like grid. I mean, we can do that beforehand here just to build the, let's call it yeah, we can call it ACK as well. So accumulator grid map. And then for each of our elements, we simply, or for each of our rows, we simply return a vector. And then we collect that. And then we say what we want is a vector of vectors of U64s. We need to set the colon. And this can be the init part, the accumulator, and then we don't need to actually check. Then we can simply say unwrap here, and then simply push, and then return the accumulator down here. So, and this should give us our elements in the correct order, and then we can simply, now we can zip them and say is operation and numbers for op in and numbers in operations zip with our we didn't give the grid name, num rows, and the num rows. No, I made an unnecessary import. So, and then we make a match over our operator. And if it's a multiple, we do something. And if it's a plus, we do something. And if it's anything else, we simply panic. Okay, this isn't okay with us because did not return a 0. That makes sense. And this is not okay because, yeah. Let's add an and here, then this is string slice compared to string slice. And then we have our numbers, and I think we should maybe just say this would be U64 add just check, does anything panic from those? Good. No, that's not what I want. I would love an add that simply panics. Saturating, yeah, unchecked add, that's probably it. Unchecked integer, assuming overflow cannot occur, calling, see, whoop. The results is undefined behavior. When checked add would return none. Oh. Yeah, but I think that should be fine here. This is the one function, and then we want the unchecked stuff. The other function, and then we can say this is the operation for our row. And then we say let mute result is equal to let's start here because the result should also be either 0 for addition, or it should be 1 for multiplication, because if we choose 0 for multiplication, then we get a 0 in the end either way. So let's use this, say this is an U64, this is a U64. And why aren't you happy? Match arms. Different in FN items have unique types even if their signatures are the same. So we should use SFN that takes in two U64s, right? Yeah, U64 onto U64. Onto U64. This is unsafe. Love me some unsafe Rust. So, what's your problem? Non-primitive cast. Do I have to... Previous cast is unsafe. Invalid cast. Wasn't that the suggestion by the compiler? Okay, let's remove that again and look again what the compiler suggests. Oh my god, I was casting the entire block. Yeah, that's of course not working. So now this is working. Okay, can I remove the unsafe? No, I cannot remove the unsafe. So we have our unsafe operation. Doesn't really matter. So for num in numbers, let's use res is equal to operation applied to res and our number. And now we have to say unsafe because this is a unsafe operation now. And yeah, this should, yeah, let mute total equal to 0. That is all right. And then we say total plus equals res. And now we have a problem because I need I64s. So where do we have our number type? Here. Changing this here, and then using an I64 here, and here, and here, here. Yeah, and here. And now we can test this. For more information, could not compile. V is mutable as it is behind a borrowed reference. Yes, can I say get mute? Accumulator is not mutable. Mutable. Oops. Yeah, of course. There it doesn't make sense. Must be in the header of a function or closure. And there's a bot again. Let me quickly remove it. Yeah, that bot was created today. Okay, so yes, I think now that we borrowed it mutably, it could work, but it doesn't want to. We get 682, but we need 4 million. I would say that's a simple rounding error. I don't see a problem with that. So, what is going on? Let's maybe check our numbers. We again have to use the debugger. Let's see. So, we have our number rows, and there's 1, 2, 3, 3, 2, 8, 5, 1, 6, 4. 1, 2, 3, 3, 2, 8, 5, 1, 6, 4. Yeah, that's not what we want. That's why it's not what we... No, that should be it, but it isn't. So I made a mistake here. Now we are iterating over the next... Yeah, I think we should completely redo this one because this doesn't make sense how it's implemented right now, and that's why we get this weird results. So for v in grid into iter dot enumerate gets us not only the next but also an index. And then we, let's call it I, and then we have j. Do we need j? let's first take J, and then this is element in next dot iter, yeah, into it, into, no, not into it. This one we need borrowed. We cannot take ownership of this one. But of course we can take ownership of you, or not ownership, but the reference here. So, and then we have to say accumulator dot get, and I think that's where my problem was. We need to get it at J and not at I, and then simply push unwrap and then push the element we have. Let's make this mutable. And now the problem, yeah, of course, we still have to say parse. I think I'm, yeah, I think I'm gonna make a type num I64 again, so that we can simply say parse to num should we ever have the idea that this should be changed. We can simply change the num wrapper. And then we of course have to say unwrap. And now this works. And we can remove this. And we can name our accumulator numRows. And then we can simply remove this. Remove the enumerate call, remove the unnecessary braces. Don't insert a while. And now this should work. Still fails because of the unwrap here. Yeah, of course, because we said grid iter. But we have to say grid first. Probably unwrap iter. Because we need the length of the first row. That's better. But how can you have a negative result? Are there negative numbers? Are there numbers you can interpret as negative? I don't see any negative number here. Let's try that again with the debugger. And the numRows are 1, 2, 3, 4, 45, and 6. 1, 2, 3, 45, 6. And 328, 64, 98. And 51, 387, 215. And 64, 23, 314. Okay. How can you have a negative result then? Let's check when res. Is res ever negative? Res is 175. That doesn't sound right. Let me quickly check Brave. No, the first result should be 33,210. And that makes much more sense in my eyes. S times num for numbers. And numbers? What? The heck? Who had that idea? What is going on? Is that mutating? Why would it be mutating the value? That doesn't make any sense. Then let's repeat that for the next. Now numbers seems all right. We do the unchecked operation. Numbers is still all right. Numbers is still all right, but now we have... That's just odd. I said unchecked sub. Okay, yeah. That makes sense that we get negative results then. I'm still not sure why the numbers were so wild, but I think that was just a problem with the debugger and not a problem with Rust itself. So let's run this. Okay, there is no actual test input yet. I'm quickly at Brave again, and then that's not a new folder, new file. Day 06, and insert that. That is Ruby. Yeah, of course, Visual Studio Code. No, I didn't want to run the test. I wanted to run the main. And that is our result here. Then now we can head over to AOC together and submit. And that's correct. So, what's the catch? The big cephalopods come back to check on how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read cephalopod math. Cephalopod math is written right to left in columns. Each number is given in its own column, with the most significant digit at the top and the least significant digit at the bottom. Problems are still separate, with a column consisting only of spaces, and the symbol at the bottom of the problem is still the operator to use. Reading the problem right to left, one column at a time, the problems are now quite different. Right to left, top to bottom? So it's only the 4. Then it's 431, and then it's 623. Of course. Yeah, that seems easy enough. Okay, let's take this over. I'm going quickly over and then taking you right with me. We now have a different test input, right? Yeah, this is a different test input. Sorry for keeping you hanging over there. So I copied it over, and now I copy this, and I take you back to Visual Studio Code again. And then we say test input B, and we can take this out of here and put it here. And as you are now test input A, you can be. So. Essentially, this part we can keep. So. Our space gets an input answer and returns a tuple of operations, tuple of vector of answers, and a vector of answers. And then it's operations grid. And then we say parse base of input. And we say let operations and grid. Okay. Then we say save this. We put the number up here. So the operations will be the easy part. So I think we could even... Yeah, we could even keep this. Because the tricky part is getting the numbers. So extract this into function and we call it sum or calculate. Okay, so this is the easy part and this is the hard part. So, let us go here and think. So here we would have 1, 2, 3, 4, 5, and 6. From top to bottom. Now the question becomes... The positioning is now not irrelevant anymore. That is so annoying. Here we have 369, 248, 8. Right? 8, 248, 369, or the other way around, doesn't really matter. Here we have 175, 581, and 32. So now the alignment matters. We cannot split on any number of white spaces anymore. But we can check our puzzle input again. Yeah, I would like to deactivate line wrapping. What the... How are we supposed to know anything here? What the heck? Okay, I think I need to deactivate line wrapping. Let's look at it in Visual Studio Code. We cannot really see anything from here. What I'm looking for, yeah, this is more like it. So there's no consistent spacing, but we can look at how many spaces are behind an operator. Yeah, I think that's it. We have to look at how many spaces are behind an operator and take as many numbers. And then we have a trailing white space, but that is all right. So we can use... We have to rewrite this again for it to actually work, or we don't really have to write it, but we have to ignore the grid here. Let's comment that out for now. We will need it later. So we have our operations. No, we cannot do it like this. We have to say input split on \n. And then take the last operator. So but actually I'm thinking right now if we could kind of slice out of the string the parts we need. Ah, this seems so odd. So yeah, I think we don't only need the last. Let's say those are rows. And then rows dot last. And here we should probably collect those into a bag of answers. So now I'm really struggling with this. So let's make a loop here. And let's make a mutable index start and end. Start is a 0. So let's assume start is already set. And we need to find the position of end now. So while an operator row at the position end is not equal to or is equal to a space. So why doesn't this work? Can't we index into a slice? Cannot be indexed. Or maybe we need returns an option and then we say unwrap. Wait, didn't it say there was a get? Yeah, so why do you need to be explicitly usize? No, that's not the problem here. The type stir cannot be indexed by usize. Slice index is not implemented for usize. I have to Google this real quick. Rust or at yeah, we have to collect them as chars. Yeah, if we collect them as chars, we can, of course, put them into a bag of char. No? Ah. Sometimes forget that we also have to use angled brackets here. So, and then we can say get and unwrap. And this is an and char. Now we know that we have a space. So why we have a space, we simply increase the end by 1. I think we need to loop here. So while we have a space, we go 1 further. And when this stops, we know we have a new operator, but the operator we currently need is at start. And that is from the rows, the part we actually need for our number. Let me think, it is from top right to bottom. So there will be something at all positions. So we could say that the good thing is that it is written from top to bottom, I think. So if we encounter, for example, a 5 at the top, no. Not working as I thought. So, but what we definitely need to do is we need the index. We need to go from start to end, excluding the end. Then we need for all rows stir in rows. We can use pop here actually because we don't need that row anymore. Then this needs to be mute, and then we won't iter over that here. What's your problem? Rows moved due to the implicit call of into iter. Rows dot pop. Where is the into iter call? I don't see. Yeah, okay, there was the into iter call. And here again. So now this is a row. Yeah, why do I call it string? This is a row, that's why I called it rows. And then we actually need to get the char at that position again. So we can actually also say chars here. Yeah, no, we can say map, take the row, say row.chars. Then we can collect this into a vec of char. Let's see. This is collect. And then we don't need to use chars here and can simply say pop under collect. What's your problem now? Ah, yeah, no, we don't even need to collect here. Nice. We can simply now pop it. So, and now we can say row get at our index. And this is now a character, and we can parse that character. So this character does definitely exist, so we can unwrap it here, but we can also say simply map c, and then say c parse. Yeah, let me quickly Google again. Must char to U64 or something. U8 would also be fine. How do we convert the char from? Okay. So we can simply say num from C. The trade from nchar is not satisfied. Do we need to? No, it's probably that we need something smaller. No. Huh. Did I read it wrong? Somehow. The question had nothing to do with what I needed. I know I did. I'm gonna show you what I'm doing if I need that long. I know that I did that. Yeah, here. Yeah, it was 2-digit with the decimal system or the system we're using. That was it. So we can say C.2-digit with base 10 and then say as num. Yeah. Yeah, okay, no. We cannot unwrap that here. And I actually don't want to map here. Yeah, it's map or. And the default would be none. So now we essentially map that to digit. We could of course say, let's not map this option here. So now we have an option and now there's either a value in it if we had a number at that position, or there's no value in it if we did not. So we can say match some num, and we actually do nothing if this is none. So let's look at our input again. This is so random. Like the base of the number is just random from its position. So you see here, this is 54. But this up here is 3. This is 44 and this is 23. So from the position of the numbers, we don't know what we actually have here. So we have to first collect them into a vector, and then we can calculate the result from the vector. So let me think again. I'm really unsure at what position we are right now. So this would be a number, or no number, of the we go through the entire row. Yeah, the first row, the second row, the last row, and then we go to the next index, and yeah, so we collect the numbers here in those rows. So we have to num_v is our vec, and then we say num_v push the number if we have one. And here we can actually say as I64. but we have to say that our num_v is mutable, otherwise this won't work. So now when we're here, we got our number for that calculation, or with the parts of the number in num_v. And then we can say num_v.len is len, and then we say num_v.fold. We start with 0. I think we need to enumerate this. And then we again have our index and the next element. And then this is 10 to the power of len minus our index, multiplied with the next value, added to the accumulator. So what's your problem? Can't call method power on ambiguous numeric type. You become an I6410. You cannot convert usize to U32 and panic if the converted value doesn't fit. So this can never be negative, so we can simply cast it to U32, there's no problem. And then we have to say for this entire part as I64. Or do we have to say here this is an I64? I mean, we should say as num to be, to do it like we did it before, and here also as num. So what's your problem? Cannot add I64 to void? Excuse me, what? Okay. Because a for loop always returns the unit type. Okay, so this is our num now. And this should actually be alright. And now we can say nums is again a vector. And we can collect nums.push num. I forgot to make you mutable, so that works. Okay. And now I think we're going down here and we have the operator and the numbers. And I want this extracted into a function. And that is calculate term. One operator, one numbers. And now we can say here, calculate. The operation is actually the operator row at the start index while the num rows is our nums. Ah, no. Arguments to these functions are incorrect. Expected struct vect answer found reference to char. Ah, because I said calculate instead of calculate term. And now this probably needs to be a reference. And what's your problem with this? Ah, expected answer got nchar. What's easier? To call to string? Yeah. And then simply reference this, and that is the term. And we make a total is equal to 0. And then we simply say total plus equals this. We can remove this. And what's your problem? Ah, okay. I accidentally deleted the closing bracket. So total. Why total is assigned to but never used. Okay, I don't see that, but all right. You think so? So this loop is never broken. That is correct. Map unwrap. We should actually use unwrap here. Let's say loop. Let's call this outer. Wasn't it like this for... There was a way to label... Add label. Ah, it's... Okay. So... Yeah, I know. We say loop and we say match. And this is inner. Oh, never mind. So we match. If this is sum of a Boolean value, if I think we can make the check here, never mind. If B, yeah, if B, no, if not B, then we break out of this loop. And if it is none, then we break out of the outer loop. What's your problem? Mismatch types. Operator expected type bool found enum. Ah, because I say unwrap here, we don't want to unwrap. Break outer, use similarity named... Ah. Like this? Yeah, break outer. Okay. So, can we not say not be here? Yeah. Okay, cool. What do you mean, of course? And in any other case, we simply say plus equals 1. There is only one other case that B is not, but yeah. Okay, so then we have to update start and end. Start becomes end. Done. Now we have to say plus end becomes end plus 1. And we also have to use end 1 here. So if this map doesn't work, that means we come in none. That means the operator row was empty. We cannot break then, though. We have to say we can actually say while none or we can actually say while RDX is smaller than operator row len. But we don't have IDX, we have to say end or start. No, let's say end. End will always be correct. Okay. So this doesn't work apparently. B is not bound in all patterns. Can I say it like this? Probably not. No, I cannot. Okay, then we do it like this and simply put another if B in here. Okay, we have to. None has to be its own. So, if not B, break. If none, break. And plus equals 1. So we will always stay 1 under end. So this catches on when end is at the end of the operator row. So when we don't have anything more, so end is 1 outside of our operator row or our entire strings. And yeah, I think this is quite complicated, but it should work. And it doesn't. But it doesn't panic. I think that's totally a success. Sorry. So, but this is test input B. Let me quickly go into the split mode and put this over here and this over here. I think, yep, that looks good. Okay. We can close this anyway, and we can close this as well. So let's have a look here. We have 1, 2, 3, 3 to 8, 5, 1, 64, yeah, 45, 6. It's actually the same input, right? I didn't have to copy it over. Yeah, okay. I thought it was something different. I thought wrong. So run tests again. So this test is failing. It's test B. And it's quite low. So then let's have a look if this is working in any reasonable manner. Debug. So, I mean, the most important thing here would be that the numbers are correct, right? So that would mean nums would have 10,243,560 is not correct. I have literally no idea what those numbers are. Look, 240. 1 becomes 10. 356. Aha. So the actual problem is my power, which is here, needs an additional -1, of course, because the power is always at least 1 if I do it like that. That doesn't make sense. So stop and rerun recompiling. So 1, yes, 24, 356, yes, multiplied with one another becomes a total of 0. What? Yeah, of course, because there's a 0 here. Why is there a 0? Why do we even have 4? Because of the last one. Of course, we have to say and -1 even. Recompiling, rerun. Yeah, now 1, 2, yes. 369, 2488. 2488, yes, perfect. 32, 581, 175, yes. 623, 431. Where's the 4? The 4 is missing because our end -1 is wrong here. Sorry. Aha. We can say and plus equals 1. And this way, even our last number, yes, 369, 248, yes, 32, 581, 175, yes, and now 623, 431, and 4. Perfect. This test should run. Yes, this test does run. Perfect. Okay, so is there still a bug? I just had an idea, but I instantly forgot again what the bug could be. I think we should just run it and see. Yes, it worked. Perfect. That was, in German you would say, a hard birth. Yeah, but it worked. 1.5 hours. I think that's all right for Rust and this task. At the beginning I thought it was really easy, but in the end, of course, it became overcomplicated again. Yeah, we could clean this code up, but honestly, right now, not today. Maybe I make a wrap up when I'm done in a separate YouTube video where I explain every solution I made. If there is, yeah, if there's any interest and I want to do it. Then I will clean it up, but otherwise I would keep it as messy as it is. So, finished. Day 6. Sync changes. Yep. So, that would be it. Then, yeah, if you're watching it on YouTube or somewhere else, thank you very much for watching. And yeah, maybe I see you tomorrow. Otherwise, I catch you in the next one. Bye.